Okay, let's look at some other examples. So for example, 12x squared plus 11x plus 2 equals 0. Again, I would like to look for a greatest common factor. This is even and this is even. However, this is not. So it's not a case where we can pull out a greatest common factor. So again, let's do the AC method. Our A is 12, B is 11, and C is equal to 2. Then A times C is 24, and B is equal to 11. So we are looking now for the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And the factors that will add or subtract up to 11, which is our B, is if I had a positive 3 and I added 8. So that means I can rewrite my original equation as 12x squared plus 3x plus 8x plus 2 is equal to 0. Then we can factor by grouping. In this grouping, the greatest common factor is 3x. And I'm left with 4x plus 1. Okay? Remember, we need the plus 1 there, so when we distribute the 3x through, it'll multiply by 1 to come back. Then in this grouping, the greatest common factor is 2, and we're also again left with 4x plus 1. And don't forget your equals 0. Now again, we have two terms. Okay? This is a first term, everything multiplied. Then this plus sign stops the multiplication. And there is another grouping. Okay? So we have two terms. And in between those terms, the greatest common factor is the 4x plus 1. So I can factor that out. And then opening up the parentheses, in the first term, then all I'm left with is the 3x. And in the second term, I'm left with the plus 2. And now it's factored, and we can use the zero product property that says either the first thing is equal to 0, or our second thing is equal to 0. Okay? And these things are called factors. Okay. So if we solve this, we'll subtract 1. So 4x is equal to negative 1, and x is equal to negative 1/4. Here, subtracting 2, 3x is equal to negative 2, so x is equal to negative 2/3. Again, we get two solutions here. Sometimes it's really helpful for us to look for a greatest common factor before we begin factoring. So for example, if we had negative 3x cubed minus 5x squared minus 2x equals 0, the degree of this polynomial is 3. This is no longer quadratic. However, if I look for a greatest common factor, I see there's negatives that I could pull out of each of them, and an x. When I do that, then I'm left with now positive 3x squared and plus 5x and plus 2. equals 0. Now this is quadratic. And let's see if we can do this one by trial and error. So negative x, don't forget to bring the negative x down. If I'm going to get 3x squared, I need a 3x and an x. Both signs are positive. And then I only have options of 2 here, 1 and 2. Okay. So if I put a 2 here and a 1 here, that would be 3x squared plus 3x plus 2x is plus 5x plus 2. Now we have multiple things being multiplied together to equal 0. And it doesn't matter how many we have. As long as they're equal to 0, it's either that the first is equal to 0 or that the second is equal to 0 or that our third factor is equal to 0. And we can solve these. So either x is equal to negative 1, or here 3x is equal to negative 2, so x is equal to negative 2/3. Or here, if we multiply by a negative 1, we'll get positive x is equal to 0. So in this case, we had a third degree equation, and we came up with 3 answers. So factoring is the easiest way we can do it. We also have some other ways to solve things. Like, for example, we have the square root property. The square root property says if we have x squared is equal to k, which is a constant, if that happens, then our solutions will be x is equal to plus or minus the square root of k. And we saw that, remember when we solved x squared minus 9 is equal to 0, we did it by factoring, by saying x plus 3, x minus 3 equals 0. So either from here x equals negative 3, or from here x equals positive 3. So in this case, if we were to solve it using the square root property, we would see then we have to add 9 to both sides, add our constant. So x squared is equal to 9. Now we're in this form. And then we can take the square root of both sides. And the thing we have to remember when we do that is that we take the plus or minus as well. So x is equal to plus or minus 3. Let's try another one. So if we had x squared is equal to 8, we could simply take the square root of both sides. The square root will undo the squaring. So we would have x is equal to, and then here's the important part that we have to remember, are plus or minus the square root of 8. And we could simplify the square root of 8 to 2 square roots of 2. Okay, so 2 different solutions. 2 square roots of 2 and negative 2 square roots of 2. These are irrational solutions. We could also do things like 4x squared plus 1 equals 7 using this method. All we would have to do is isolate this x squared, right? Get it by itself. So if we subtract 1, 4x squared then is equal to 7 minus 1 is 6. And dividing through by 4, we would have x squared is equal to 3 over 2, okay, reducing 6 over 4, so that x would be equal to plus or minus, so I'm going to take the square root, the square root of 3 over 2. We could rationalize this. Okay, remember this would be plus or minus the square root of 3 over the square root of 2. That's just rewriting this radical with the fraction. Then if we rationalize it, up top we would get the square root of 3 times 2 is 6. The square root of 2 times the square root of 2 is 2. And don't forget the plus or minus. It'll also work if we have a quantity that's squared. So say, for example, if we have this. Okay? It's no longer x that's being squared. It's the quantity x minus 4 that's squared. But we will think about this just as the x squared. So step 1, let's isolate the quantity, that is, undo everything that's happening to it. Okay. Now the 3's will cancel, and we have x minus 4, that quantity squared is equal to 5. Now that this is isolated, we can take the square root of the quantity, and on both sides. The square root will undo the squaring, so this is x minus 4 is equal to, and don't forget this, plus or minus the square root of 5. And now we've almost solved for x. Right now, 4 is being subtracting, so all I have to do is add 4. That will make those go to 0. Now here, 4 and the square root of 5 are not like radicals, so this becomes, I've added 4, and then we write plus or minus the square root of 5. This is two solutions. One is 4 plus the square root of 5, and the other is 4 minus the square root of 5. And notice that that was much easier than squaring this thing out and trying to factor it. And that's where a method called completing the square comes in. So let's talk about that. Okay, completing the square. The square. Okay. Now there's a methodology for completing the square, and we have to remember what they are. So number 1, and by the way, I'm not going to write out completing the square every single time, so I'll abbreviate that CTS. If we are going to complete the square, the coefficient on x squared must be 1. If it's not 1, we will have to manipulate the equation so that it will become 1. Okay. Let's do an example while we're doing this. So x squared plus 4x plus 4 equals 3. In this case, we can complete the square on this because the coefficient on x squared is 1. When I'm completing the square, then the second thing I do is move the constant over. So in this case, 4 is a constant. I'm just going to work with this to complete the square, these two terms. So I'd like to move it over. And to do that, I need to subtract 4. And that will give me negative 1. Minus 4, minus 4. Okay. And then what I do is I like to prepare to complete the square. It's a way that I dummy-proof myself, because what I'm going to do here is I'm going to add something to this side. And I say dummy-proofing because oftentimes what I do is I add to this side, I figure out what number needs to be here, but I forget to do it on the other side, so that's why I draw the 2 blanks in, just to remind myself. Now the question is, I would like to rewrite this as some quantity squared. So for example, in this equation, x squared minus 4, x minus 4 squared, we could write it as x squared minus 8x plus 16. And then we could have multiplied this thing by 3 and then dealt with the 15. But this is x minus 4 squared, and once it was written like that, notice all I had to do was isolate the x minus 4, and it was quite easy to solve. So that's our goal here. We want to write this as x, some quantity squared, is equal to a constant. And the way we do that is you divide b by 2. Okay? Alright. So in this case, b is 4. So we're going to divide 4 by 2. That's the number 2. Okay? And then we need to square that result. Okay? So in this case, our result was 2. That needs to be squared, and that result is 4. This is the number that I need to add to both sides. Now, you can write 4 in here, but then you're just going to have to unfactor it. So I always write 4 as 2 squared. And here's why. Because now that I've added this result to both sides, I know that this will collapse into 2 was positive, so this is plus 2 squared. And on this side, we get 4 minus 1 is 3. Okay, so we divide by b by 2, we square results, and add to both sides. And by doing that, I just completed the square. Now let's solve this. So we have the quantity x plus 2 squared is equal to 3. So I can take the square root of both sides. So x plus 2 is equal to plus or minus the square root of 3. And then subtracting 2. So x is equal to negative 2 plus or minus the square root of 3. Let's try some more. X squared minus 6x is equal to 13. So in this case, our criteria is met. The leading coefficient is 1. I actually already have the constants moved over, so I only have variables on this side. So let's prepare x squared minus 6x. I'm going to add something to this side, but once I add something to this side, I also have to add it to the other. Now I take the coefficient on x, which is our b. Okay, now we have to be careful to bring this negative along. Okay, negative 6, that has to be divided by 2. That's equal to negative 3. Now that result, the negative 3, needs to be squared, and this is the number that we will add to both sides. Okay. So on this side I write the 9, and on this side I write negative 3 squared. That's my own methodology. Okay. And now I know that this will collapse into x, some quantity squared, is equal to 9 and 13 is 22. And here's specifically why I write it this way. By leaving the negative in here, I know then that this collapses into x minus 3 squared. You can do it any way you'd like to do. Alright, now we can take the square root of both sides, and we're just steps away from being finished. So we have x minus 3 is equal to plus or minus root 22, and then adding 3 to both sides, x is equal to 3 plus or minus root 22. And these are our solutions. So when the coefficient b here is even, completing the square is very easy to do. Okay? But it can still be done even if it's odd. So let's try one of those. So we have x squared minus 3x minus 5 equals 0. The coefficient on x squared is 1. That is good. Okay. Now let's prepare. So I want x squared minus 3x. I'm going to add something to this side. Let's move the constant over. And then I also am going to add something to this side. Now, we look at b. In this case, b is negative 3. We have to take negative 3 and divide it in 2. And that is as simplified as it can get. Negative 3 halves is negative 3 divided by 2. So I need to square that result to get positive 9 over 4. That's what I add to this side. And on this side, I write negative 3 halves squared. I know this will collapse into some quantity of x squared. Okay. And from that, I look right in here. X minus 3 halves squared. Now I need to add these together, and this is like 5 over 1. So let's get a common denominator while we're at it. Okay. So this is over 4. In the first part I have 20, and then I'll add the 9. And that's equal to 29 over 4. Okay. So from here, we can take the square root to get the quantity x minus 3 halves is equal to plus or minus the square root of 29 over 4. And let's simplify this. This is plus or minus the square root of 29 over the square root of 4. And the square root of 4 is a perfect square, so this is plus or minus root 29 over 2. So let me just recopy that. Okay. So now we have x minus 3 halves is equal to plus or minus the square root of 29 over 2. And I want to add 3 halves to both sides. So x, this will go to 0, will be equal to 3 halves plus or minus root 29 over 2, which we could write as 3 plus or minus root 29, all divided by 2. Again, 2 solutions that are irrational. Okay, so completing the square will work in any case. It's easier when b is even, but it will always work. And let me show you why it will always work. Okay. So, here we go. Let's complete the square on ax squared plus bx plus c is equal to 0. Alright. Now, to complete the square, we need the leading coefficient, that is the coefficient on x squared, to be equal to 1. And in this case, it is not equal to 1. It's equal to a. But we can solve that by dividing everything by a. So now we have x squared plus, and I hope you'll agree with this, b divided by a times x. Okay? Because you can think about this as x over 1, and then we would get bx over a. Okay? Plus c over a, and 0 divided by anything that's not 0 is 0. A cannot be 0. If a was 0, we would simply have bx plus c, and that would be linear. Okay. Alright. Now let's prepare. So x squared plus b over ax. I'm going to add something to this side. I want to move this over because it's a constant. There's no x involved. So to do that, I would have to subtract c over a. And then I'm going to add whatever I add here there. So now I have a fraction for my b. That's all right. b, that is the coefficient on x. Okay. I need to divide that by 2. Okay. So I need to take this and divide by 2. Okay. But remember, dividing by 2 is the same thing as multiplying by a half. So what I'm adding here is b over 2a. Okay. That's the result of dividing b over a by 2. And then we need to square that. which is equal to b squared over 2 squared is 4 and a squared is 4. So this is what's going to be added, b squared over 4a squared. And here, I'll leave this as the quantity that's squared, so I know how it'll complete the square. Now this will collapse into x, some quantity squared, and that quantity will be what's inside of here, b over 2a. This quantity is positive, so we put in a plus. And equal to, now I need to add these two. I'm very close to having a common denominator. I simply have to multiply this by 4a to get to 4a squared, and this by 4a. So this is 4a squared will be our denominator. And we have minus 4ac plus our first one, which is b squared. Now we just need to take the square root. We're trying to get to x, so we'll take the square root of both sides. The square root and the squaring will undo each other, and we have x plus b over 2a must be equal to plus or minus, and let's split these up, the square root of minus 4ac plus b squared over the square root of 4a squared. Just splitting this radical. And why that was helpful to us is then that the square root of 4a squared, well, the square root of 4 is 2, and the square root of a squared is just a. Up top, we still have the square root. And let me commute these, okay? So this becomes b squared minus 4ac. I hope this is becoming familiar to you. Now I need to solve for a. So to do that, I need to subtract minus b over 2a. And when I do that, what we come up with then is x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. These have the same denominators, so oftentimes we'll see it written like this, as negative b plus or minus the square root of b squared minus 4ac. And through completing the square, we've seen then that any quadratic can be solved. The solution will have this form, and this form is also known as our quadratic formula. So let's try solving a few with that. So we have x squared plus 5x plus 1 equals 0. So this is a candidate to do completing the square because the leading coefficient is 1. However, this is odd. So when I divide it by 2, it's going to get a little messy. It can be done. So perhaps we want to do the quadratic formula. So a is equal to 1, b is equal to 5, and c is equal to 1. So x is equal to negative from the formula, negative b, which is 5, plus or minus the square root of 5 squared minus 4, I should put everything in parentheses, times a, which is 1, times c, which is 1, all over 2 times a, which is 1. So yes, you're going to need to know the quadratic formula. And now let's simplify. So this is negative 5 plus or minus the square root of 25. 5 squared is 25 minus 4 all over 2. Continuing to work with the order of operations, we'll work underneath here. The grouping symbol of the radical, plus or minus the square root of 21 over 2. And then we want to double check that this is simplified. So the prime factorization of 21 is 3 and 7. This radical cannot be simplified, so we don't need to worry about simplifying our answer any further. Okay, let's do one more with that. For example, 9x squared plus 3x minus 2 equals 0. So in this case, a is equal to 9, b is equal to 3, and what we have to be careful about, c is equal to the negative 2 because of the subtraction. And then I would write down the quadratic formula every time you do a problem until you get it memorized. Don't substitute in first. Write the problem down. Negative b plus or minus b squared minus 4ac all over 2a. And now we can start substituting. Okay. So negative from the formula, b is 3, so negative 3 plus or minus the square root of b squared minus 4 times a, which is 9, times c, which is negative 2. And then all of that goes over 2 times a, which is 9. Now we can simplify. Negative 3 plus or minus, underneath the radical, 3 squared is 9. Okay. And then I deal with the signs here next, okay? A negative and a negative become positive. 4 and, well, let's see here, we can commute this. 4 and 2 are 8. 8 and 9 are 72. And divide that by 18. Continuing to simplify, we have negative 3 plus or minus the square root of 81 over 18. But we certainly can simplify that radical. So we get negative 3 plus or minus, well, the square root of 81 is 9. And then we divide that through by 18. Now here's a case where we're not going to just leave it. Had we had a radical, we just left it because the 3 and the radical wouldn't combine. However, 3 and 9 are just integers. We can do that. So we have two solutions. This is negative 3 plus 9 over 18 and negative 3 minus 9 over 18. Negative 3 plus 9, well, that's just 6 over 18. And this can be reduced. 6 goes into itself and in once and into 18 3 times. So our first solution is 1/3. Here, negative 3 minus 9 is equal to negative 12 over 18. And this can also be reduced. 6 goes into 18 3 times, and 6 goes into negative 12 negative 2 times. So this, our second solution is x is equal to negative 2/3. So it was interesting to see what happens underneath this radical. It'll determine what types of solutions we have. Like, for example, once we finished simplifying this, we came down to the square root of 21, and it was irrational. So we have two solutions, the negative 5 plus the root 21 divided by 2, and the negative 5 minus root 21 divided by 2. Two irrational solutions. However, in this case, once I've simplified b squared minus 4ac, it's simplified down to 81. And when we took the square root of 81, it's a perfect square, and hence we were able to add our numerators, okay, and we came up with two real number solutions that were not irrational. Okay? They were in fact rational. Okay? All right, and so there is some, the way our solutions will occur, there's one other way this could happen. We could also get 0 underneath here, and then we would have plus or minus the square root of 0, which is just 0. Okay? So these types of solutions, well, it's called the discriminant, b squared minus 4ac. So let's talk about that as our last thing for the day. So, definition, b squared minus 4ac is called the discriminant. And it determines our types of solutions. So case 1 is the last one I mentioned. Either b squared minus 4ac equals 0, and hence you get the square root of 0. When that happens, you get one rational solution. Okay. And this will then be known as a double solution, which we'll talk a little bit more, well, we'll talk about more later. Okay. But it'll be a double. Or b squared minus 4ac could be greater than 0, hello?